this lesson, we are going to discuss how to convert recurring decimals into fractions. Recurring decimals have one or more repeating numbers or a sequence that repeats infinitely after the decimal point. The infinitely repeating portion should not be 0. Recurring decimals can be shown to be rational. A rational number is a number that can be expressed as P over Q, where Q is not equal to 0. This can be done by expressing the recurring decimals in fraction form, so that we have this form P over Q, but Q should not be equal to 0. How do we write recurring decimals in short form? 1. Given 0.1 with a dot on top of 1, this means that 1 is repeated infinitely. So it can also be written as 0.1 with a bar on top of 1, meaning the same, that is 1 being repeated infinitely. So this can be written as 0.1111. We can continue writing 1 as long as desired, but because we cannot exhaust this repetition, we show these with 3 dots, meaning that ones continue. Another example is 0.12 with a dot on top of 2. This shows that it is only digit 2 that repeats up to infinity. This can also be written this way, 0.12 with a bar on top, and so this simply means that this is 0.122222, 2 continues, so we show these with 3 dots. Another example is 0.25 with a dot on both 2 and 5, meaning that both 2 and 5 are repeated in that order. So this can be written as 0.252525 ... to mean that 2, 5 can be repeated infinitely. Another example is 3.123. We can see that the dot is on 1 and 3. This means that even 2 is included, so the repetition takes place for the 3 digits after the decimal point. So this can be written as 3.123, 123, 123. 123 repeats itself, so we can show this with 3 dots. Examples of how to convert recurring decimals into fractions. Convert the following recurring decimals into fractions. A. 0.3333 ... Solution. Let n be equal to 0.3333 ... Let this be our first equation. Then we multiply the whole equation by 10. So this gives us 10n equals to 3.3333 ... This is our second equation. Now let us look at the first and the second equation. Suppose we subtract equation 1 from equation 2. Are we going to eliminate the fraction part? Of course, we will have eliminated. So let us eliminate, since our interest is to do away with the decimal part. So we have 10n minus n, and this gives us 9n, then equals to 3.3333 recurring minus 0.3333 recurring. This gives us 3. So we need to divide both sides by 9 to make n the subject. So by 9 we have 1, by 9 we have 1. Then on the right hand side we have by 3, 1, and then denominator by 3, it gives us 3. So it simplifies to n equals to 1 over 3, implying that 0.3333 dot 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 equals to 1 over 3. Question B, 0.16 with a dot on top of 6. Solution. This means that 6 is the only digit that is recurring. So this can be written as 0.16666 3 dots. So let n be equal to 0.16666 3 dots. Then we label this as our first equation. We can multiply our first equation by 10 to give us 10n equals to 1.6666 3 dots, and this is our second equation. If we get the difference between equation 1 and 2, the decimal part will not be eliminated. So we can multiply equation 2 by 10 to have 100n equals to 16.6666 3 dots, and this is our third equation. If we inspect the three equations, we would take note that if we subtract equation 2 from equation 3, the decimal part will have been eliminated. So let's do that. 100n minus 10n gives us 90n equals to 16.6 recurring minus 1.6 recurring gives us 15. So we need to divide both sides by 90, and once we do this, we simplify by cancelling out. So by 90 we have 1, by 90 we get 1, and by 15 we get 1, by 15 we get 6. So it means that n equals to 1 over 6, and therefore the implication is that the solution to our equation is 1 over 6. Question C, 0.90 with dot on both 9 and 0. Solution. This can be written as 0.909090 dot dot dot. Let n be equal to 0.909090 dot dot dot. Call this our first equation. If we multiply the first equation by 10, we have 10n equals to 9.090909 dot dot dot. This is our second equation. If we look at the first and second equation, if we get the difference, we will not have done away with the decimal part. So let us proceed and multiply our second equation by 10. So this gives us 100n equals to 90.909090, and call this our third equation. Now let us inspect the three equations. Which one can we subtract from which one to eliminate the decimal part? Of course, we can subtract equation 1 from equation 3. So 100n minus n, this gives us 99n equals to 90.909090 dot 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 minus 0.909090 dot dot dot. This gives us 90. So we can divide both sides by 99. So we can now simplify. Then simplifying, we divide by 99, we get 1. By 99 we get 1 as well. Equals to, on the right hand side, by 9 we get 10, and denominator divided by 9, we get 11. So n equals to 10 over 11, implying that 0.90 dot dot on both 9 and 0 equals to 10 over 11. Option D, 0.123 dot on 1 and 3. Solution. It can be written this way: 0.123, dot dot dot, meaning that 1, 2, and 3 are repeated in that order. Let n be 0.123, dot dot dot. Let's call this our first equation. Then we multiply by 10 to give us 10n equals to 1.23, dot dot dot. This is our second equation. We multiply again by 10, so it gives us 100n equals to 12.3, dot dot dot. This is our third equation. If we look at the three equations, there is none of the pairs whose difference gives us a whole number without the decimal part. So we multiply equation 3 by 10, and this gives us 1000n equals to 123.123, dot dot dot, naming this as our fourth equation. Inspecting the four equations, there is a pair whose difference gives us a whole number on the right hand side without the decimal, and this is the first and the fourth. So let us subtract the first from the fourth. This is 1000n minus n. This gives us 999n equals to, if we get this part minus this one here, we have 123. So let us now divide both sides by 999. Then simplify. By 999 we get 1, and denominator by 999 we get 1. Then on the right hand side we divide this by 3, it gives us 41. 999 by 3 gives us 333. So n equals to 41 over 333, implying that 0.123 dot on both 1 and 3 equals to 41 over 333. Question E, we have 0.125 dot is on 2 and 5. Solution. This one can be written as 0.1252525 dot dot dot, meaning that it is only 2 and 5 that are repeating infinitely. Let n be equal to 0.1252525 dot dot dot, and we call this our first equation. If we multiply the first equation by 10, we get 10n equals to 1.252525, and that is our second equation. Suppose we subtract 1 from 2, we will not have eliminated the decimal part, so we can multiply equation 2 by 10, and this gives us 100n equals to 12.52525 dot dot dot. This is our third equation. If we look through the three equations, is there any equation that leaves the right hand side without the decimal point or the decimal part? There is none. So what do? We multiply equation 3 by 10. This gives us 1000n equals to 125.252525. Then we name this as our fourth equation. If we look at the four equations, now there is a pair that can give us a whole number with the decimal part eliminated. And what is this pair? This is actually second and the fourth, this one and this one. So if you look at this, you will realize that the decimal part is the same as this decimal part, meaning that if we subtract, that decimal will be eliminated. So let us subtract equation 2 from equation 4. This gives us 1000n minus 10n, giving us 990n. Then this part minus this one here, it gives us 124. We now need to divide both sides by 990. Then this means by 990 we have 1, and by 990 we have 1. Then on the right hand side, if we divide 124 by 2, this gives us 62, and by 2 on the denominator, this gives us 495. So n equals to 62 over 495. Then it means that our solution is 62 over 495. Now you can try out the following few questions. Express the following in fraction form. A, 0.5555 ... B, 0.27 with a dot on 7. C, 0.032 dot is on 3 and 2. D, 0.215 with a dot on 2 and 5. Thank you, and I hope to meet you in the next lesson. Goodbye.